I forgot, like the new version of PowerPoint like automatically starts this recording when I don't necessarily want it to start, because I was looking for something. Oh, I found it. Good. Okay, so this video, if I can get my act together, is to go over the study guide for the in-class test, and this is to be completed before our actual review day. There will be an assignment embedded in this video, so be sure to watch the whole thing so that you are able to complete that assignment on time, and it should really help you review, study, and prepare for this test so that this test can be as good as it possibly can be for you. I will also be referencing the actual test to give you information about the number and types of problems that you'll see so you can be as prepared and as confident as possible. So if I can figure out how to work this, there we go. Okay, so first item on the study guide is to be able to simplify radicals of any index. There are 4 problems of this type. Now there's only 1 on your review sheet because like you really don't need to practice like a million problems unless you feel like you need to. So if you feel like you need to do more, you go back to your homework, okay? And that's going to give you a bank of problems that you can practice from on your homework that hopefully also have solutions to them because we did review that in class. But for your study guide, we're just going to go over 1. So in order to simplify radicals of any index, first you need to remember what the index does. That's your index right there, and that tells you what this particular radical undoes. So this is a cube root, and so it undoes cubing. Our strategy for doing this is to get the prime factorization of everything under the radical and then look for, in this case, groups of 3. But if it were an index of 4 or 5, you'd be looking for groups of 4 or 5. If it's just a regular radical, we assume that it is groups of 2, that it is a square root. And the reason for that, okay, is because cube rooting undoes cubing. So if you have something, you cube it, you cube root it, it brings you back to wherever you started, like in that case, x. So also important to remember is that this is multiplication right there. If you can see where my blue dot is going. So that is 2 times the cube root of. So as I bring this down, I'm going to bring that down as 2 times. And then we stretch our radical out a long ways. 81 factors into 3 times 3 times 3 times 3. Remember that the number part of that usually is the most complicated part. Use the margins of your test. Use a piece of scrap paper. Try not to put that in the middle of your work. All right, and then we have x times x times x and y times y times y times y times y. And we are looking for groups of 3. So I have a group of 3 3s. So remember the cube root of 3 cubed is 3. And so that comes outside of the radical. That's like where it goes and why there's only 1 of them, because you undid the cubing. And it should come outside. I have a group of 3 x's. And so that comes outside, and here I have a group of 3 y's, and so that comes outside. And then everything that is left, we have a 3 and we have 2 y's. And then outside the radical, we do have a 2 times 3 there. So we can make that a 6, and there is our answer, and that gives you full credit. A couple of things I want you to remember about doing these. 1, don't forget to keep the index, okay? So you can't drop, like if it's a cube root or a 4th root, you can't drop that. If you drop that, it is considered wrong. Also, they do stretch out a long ways, and when I don't want to like hold the test up in front of the screen, but when I was taking the test, I had to write pretty small, and it you're just kind of running out of space horizontally. So I'm going to give you a heads up about that. It is a little bit crowded when you start to write it out, because one of them goes up to like an exponent of 7, and there's like 6s and 7s, so you end up with these long things. It doesn't really make the problem any harder, but it does make it a little bit hard to fit on the page. If you want to use a piece of notebook paper instead to just give yourself some more space, that's fine during the test. Just make sure you ask about it in advance. So there are 4 problems of that type on your test. Next one is be able to add, subtract, multiply, and divide radicals as indicated. Answers should be simplified as much as possible. So key idea here is that when you're adding or subtracting, the radicands have to match, okay? And so what we have here with we have subtracting, adding, this one's multiplying, and then this is a division one. But you have the adding and subtracting, the radicands have to match. So 45 does not match with 80, 5 does not match with 10. So at first you might think, oh, I can't add or subtract those. But before you are allowed to conclude that, you do have to try to get them to match by simplifying them as much as possible. So I'm going to go ahead and do the square root of 45 times the square root of 80. I'm just going to simplify the radicals 2 different ways on that one, just to review them. So one of the ways that you can simplify it is by getting the prime factorization, because everything we did in the previous bank of problems applies to this. So off to the side, you might do something like this. 45 factors into 9 times 5, and then 9 factors into 3 times 3. Don't forget that the 5 is there. Some of you, when you're doing your factor trees, you leave things, you don't bring them down to the next line. And that's technically that's fine to do, except that there's a tendency to leave them out, and then you end up dropping a factor. So we can factor this into 3 times 3 times 5. That is a square root. Okay, that is the assumption. So we're looking for groups of 2. So the 3 comes out and the 5 stays in. Now, you don't have to go all the way to your prime factorization on that. Okay, so you can do it this way. So I'm going to do this one a different way. 80 is the square root of 16 times 5. And so we would have the square root of 16 times the square root of 5. And the square root of 16 is 4. And so what we end up with is 3 root 5 minus 4 root 5, which is negative 1 root 5. Or you could just say negative root 5. Okay, that would be fine as well. So you do have to try to get those to match before you are allowed to conclude that they can't be added or subtracted. How you do that simplification of the radical is up to you. Some of you have calculators that will simplify it for you. Not this kind of calculator, but I have other calculators that do simplify them. And if you've got a calculator that does it, awesome, you're allowed to use it. So that's that kind of problem. Now with the second one there, this one, those are actually already simplified, and so you can't add them. And that's how you have to answer the question. Like, I can't add these. They're not the same, and you can't make them be the same. So you're going to see a problem like the first one. You're going to see a problem like the second one, that you can't add them. So don't try to do stuff you can't do. Next one is the cube root of 4 times the cube root of 3. And when you're multiplying or dividing, you actually can do that with unlike radicands, and that's why it's important to practice each skill as you go. So this would be the cube root of 4 times 2, which is the cube root of 8. And so what number cubed gives you 8? That would be 2, or you can do the prime factorization on that and simplify that. You may also see a division problem the same way. So you might see something like, I don't know if I can pull one up. I don't want to take one off the test because that's kind of bad form, but you can do the same thing with division. So you could see the square root of 8 divided by the square root of 2, which is the square root of 8 over 2, which is the square root of 4, which is 2. Okay, so you can see a division one. The last one on there is the kind where you have to rationalize the denominator. And that is a much longer problem. And I'd say I'd like to come back to it, except that with PowerPoint, it doesn't let me cycle back once I click off the slide. So in order to do this, remember the goal is to get rid of the radical in the denominator, and that the way we do that is by multiplying by the conjugate. Now, any of these concepts that you feel are like, wait a minute, how did she know that? That means you need to go back and watch the video for that lesson, or you can do the assignment at the end of this, and we can kind of address the question that way. But the conjugate of 2 minus root 5 is 2 plus root 5. And because we have to make sure we multiply by the number 1, we have to multiply top and bottom by the same thing. And then we just have to grind out the multiplication. So one of the ways that you can do this is through foiling. So I'm going to model foiling for you. So you can do first, so 1 times 2 is 2. Outer, 1 times root 5 is root 5. Inner, root 2 times 2 is 2 root 2. And last, root 2 times root 5 is root 10. And the great news about that is that you can't simplify that. You got a root 5, a root 2, and a root 10, and they are not the same, and you can't make them the same. So that's really all you had to do. Now, the other way you can multiply them is by using the area model, which I know a lot of you prefer. So for the second multiplication, I'll use the area model just so we can review all of this. So the area model, you set up your rectangle, and we've got 2 minus root 5 times 2 plus root 5, and then we find the area of each rectangle and add them together. So 2 times 2 is 4. 2 times negative root 5 is negative 2 root 5. 2 times root 5 is positive 2 root 5. And negative root 5 times positive root 5, a negative times positive is going to give you negative. And then root 5 times root 5, I would just follow what I'm saying because I don't want to have to write it all down. So root 5 times root 5 is root 25. And the square root of 25 is 5. Okay, now the great thing about conjugates is that those guys cancel each other out because you're going to add them all up. And we are left with 4 minus 5, which is negative 1. And you can leave that as is. You could also divide all of it by negative 1. It will flip the sign, so you'd have a negative 2 minus root 5 minus root 2 minus root 10. I'm not convinced that's simpler, so I would honestly just leave that as is. Okay, now there is a problem on your at-home test that is like that. So if you haven't tackled your at-home test and you're not sure how to navigate through that, this review can help with that as well. So you might want to pause the video, hop over to your at-home test, find that problem, and then do it while it's fresh in your mind. So there are 5 problems on your test that involve adding, subtracting, multiplying, and dividing radicals. And it's kind of like the last test where I renumbered something. I took a problem out and it threw up all the numbering. I didn't want to go through the whole test and renumber everything because that's annoying. So it's like for problems 5 through 10, and there's no number 7. So it goes 5, 6, 8, 9, 10. You can thank me later for taking one of the problems out. All right, next category of problems is be able to simplify expressions involving exponents. Answers should only have each factor written once. That means, so you know what that means. This piece of the direction should only have each factor written once. Means like, see how there's an x in the numerator, x in the denominator. You can't have more than one x. So there should just be like one x somewhere. But you got to get all the x's together into just one. You can't have an x in the numerator and an x in the denominator, or 2 x's in the numerator, or anything like that. And should have no negative exponents. We need to manipulate all those negative exponents away. There are 1, 2, 3, 4, 5 problems like this on your test, and they vary in difficulty. So some of them are very straightforward and some of them are harder. Use your judgment when you're looking at the test problems. If it looks like something you can do fairly quickly, get it done. If it looks like it's going to take you a long time, skip it. You can come back to it. Just allow yourself the time to think through it. So for this first one, we have 4x to the negative 3 over 2x to the 4th y to the negative 2. So again, this is hard for me to kind of go over because I have my own style for doing these, and my style might not match your style. So if you're looking at that and you're like, well, I would divide 4 divided by 2 first, that's totally fine to do. But other people might say, well, I would move the negative exponents around and make sure I got all positive exponents first. So some people might say, oh, I would do x to the negative 3 over x to the 4. That's x to the negative 3 minus 4 to get x to the negative 7. So there's more than one way to do this. I'm just going to review it the way I would do it, and what I think is going to be the best explanation for you guys. So looking at this, you can actually break it into little mini problems, all right? And then we would use a 1 in the numerator of that fraction. So what I did there was I just kind of broke it up into okay, let's look at the constants, let's look at the x's, let's look at the y's, and we'll just tackle each one. So that is 4 divided by 2. Make sure that you're not subtracting. I know 4 divided by 2 and 4 minus 2 are actually the same thing, but that's the only time that happens. So So 4 divided by 2 is 2. It's a regular 2, so it should be in the numerator. If you put it in the denominator, it's actually 1/2. Then for the x's, I'm going to take that x to the 4th can stay where it is. And I'm going to take that x to the 3rd, and I'm going to move that into the denominator, and it becomes x to the positive 3, and then we're left with a 1. And then y to the negative 2, if I move that into the numerator, it would become y to the positive 2. And then technically you have a 1 down there, but nobody writes it. Like kind of same over here. And then we could just multiply all that together. So my numerator is 2y squared. My denominator, I have x to the 4th times x to the 3rd. And remember, we add exponents, so that gives me x to the 7th. Not the only way to do that. Now, notice that like we only have one constant. We have one y. We have one x there. Like, so we don't have, like this is what we're trying to avoid, is like having more than one x. You need to make sure you combine them so you only have one, and all of our exponents are positive. So that's how we know that we finished that problem. Second one, we have 2x to the 3rd over 4x to the negative 2. So for this one, some of you might recognize that if you have 2x to the 3rd, that's 2 to the 3rd x to the 3rd, and 2 to the 3rd is 8. Okay, and you might do it that way. Some of you might look at that and say, well, I'm not totally sure what I should do with the 2. I know it should be x to the 3rd, but what do I do with the 2? So if that's you, go back to your definition of what exponents are. To cube something, okay, so to have this being cubed, to cube something means to multiply it by itself 3 times. So that is 2x times 2x times 2x, and then we have 4x to the negative 2. 2 times 2 times 2 is 8. X times x times x is x to the 3rd, and then we have 4x to the negative 2. Now, when this isn't quite done. We have 8, so I'll kind of do what I did in the first problem there. We'll kind of split it up visually. You don't have to write it that way. 8 divided by 4. Make sure that that's still division. It's always been division. It's not going to change. So 8 divided by 4 is 2. And then for the x's, we have x to the 3rd, and then we're going to bring that x squared up to the numerator, and that becomes 2x to the 5th. So that one is 2x to the 5th. Now, I did this in 1, 2, 3, 4, 5 steps in the review. If you looked at the work that I actually did when I did your study guide out, I did it in 2 steps. Okay, so it's possible to do this faster. However, it's not possible for most of us to do the entire thing in our head, and it's really dangerous to do that during a test. So please don't do that. Just please don't. Like, show some work on these. Last one is 2x to the 3rd to the negative 2. So first thing I see there is oh, we've got that negative 2. I can move this whole thing down and make the exponent positive. And then to square something means to multiply it in twice. So I have 1 over, and then 2 times 2 is 4. X to the 3rd times x to the 3rd. You add exponents, getting x to the 6th. So these are about the same level of difficulty that you're going to see on your test. There are 3 of them on the study guide, and again, there are 5 of them on your actual test. Some of them are easier than others, but they're all in the same family, and there's more than one way to do them. So if you start a problem and you kind of start spinning your wheels, kind of like you're getting stuck in the mud, don't erase your stuff. Like, please don't ever erase your stuff, because you probably have more correct than you think you have. But maybe leave the problem, go on, do something else for a little bit, and then come back to it and maybe try something different. Okay, you can, sometimes that'll get some cobwebs out. All right, next, there's, I left out a chunk. Okay. All right. Well, I can't navigate around this. I know what I'm going to do. I'll have to back up and do it. So if you're looking at your study guide, you'll notice that this slideshow just skipped over switching between radical notation, exponent notation. I promise I'll come back to that. I know there's space on the very last slide here. I can come back to it. Sorry. It is still early in the morning when I'm recording this. So let's go on solve the simple radical equations using the methods covered in class. What that means is that I shouldn't see weird methods that are coming off of like the internet, and a lot of times the internet shows you like collegiate ways to do it or ways that involve techniques that we haven't covered. You should never, ever, ever be trying to adapt to or learn a technique that you don't understand. So I really, really, really try to approach these in the way that you guys are going to understand best. So in class, we went over a 3-step strategy that looked like this. Isolate the radical, undo the radical, and then solve the resulting equation. Okay, which in this case is going to be linear. I'm not slamming you with anything that's not linear. So for this first one, we have the cube root of x minus 1 equals 4. And so isolate the radical means you get the radical all by itself on one side of the equal sign. The radical involves the index, the actual radical symbol, and the radicand, anything that's under it. So if you notice on this one, there isn't anything else over there. So for this one, the first step is actually done. Now we want to undo the radical. So you have to look at what kind of a radical it is. This is a cube root. So to undo it, I will cube it. I'm going to cube the whole radical. And then because equations are equations in math, you have to do the same thing to both sides. So I'm going to go ahead and cube the 4. When you do that, you just get the radicand. And then you can use your calculator, which I encourage you to get for this, to cube the 4. You should not be doing anything else with the radicand. You shouldn't be having like x cubed or anything. The cubing is undoing the cube rooting so that you can get at what's underneath. And then in this case, we will add 1 to both sides. So x is equal to 65. Okay. Next one, we have 3. And remember, that's 3 times the square root. Okay, we don't have like mysterious operations and stuff in math, like everything is something we know. Here's the radical, okay? It's in a square root, so the index is 2, and there's your radicand. So what you want to look at is there, oh, and notice this, like I almost need to go and make this a little bit longer because it does matter how long your radical is. Like that's not something that you can just like change the length of your radical, okay? So you'll notice in this case that we actually do have something on that side with the radical that's not a part of the radical, and in order to carry out step number 1, we need to undo that. This is multiplication. So if I want to get rid of this, I will need to divide both sides by 3. And that will give me the square root of 2x minus 3 equals 4. You will also see problems that involve like adding or subtracting the same thing to both sides. So make sure that you review the homework and the classwork and the examples to make sure you know what that looks like. Now we'll undo the radical. This is a square root, and we undo a square root by squaring. So we get 2x minus 3 equals 16, and then step 3, solve the resulting equation. So in this case, we add 3, and we get 2x equals 19, and then divide both sides by 2. And I know I mentioned this in class, but leave it as a fraction. Don't do stuff that you don't need to do, okay? Just don't do it. All right, this last one involves 2 radicals, but if we look at that first step, isolate the radical means to get by itself, and you'll notice that we do have a radical on the left and a radical on the right, but they are both actually isolated. So that brings us to that second step, which is just to undo. So if I have the 5th root of 2x and the 5th root of 3x plus 1, I can undo a 5th root by raising it to the 5th power. That'll give me 2x equals 3x plus 1. Now you can solve this. You can either subtract 2x from both sides or you can subtract 3x from both sides. I don't know that one way, like they're both going to end up being a 2-step process regardless of which way you do it. If you subtract 2x from both sides, 2x minus 2x is 0. And then subtract 1 and you get -1 is equal to x, okay? If that 0 there just gave you the heebie-jeebies, All right, you can do it this way. You can subtract 3x from both sides. This will give you negative 1x equals 1, and then divide by negative 1. And either way, you should be able to arrive at x is equal to negative 1. So you can pause the video and kind of study that and make up your mind about like which way you're more comfortable doing that. There are 4 radical equations on your test, including one that has a rational exponent, which we did cover in class. So I strongly encourage you to go back to your notes and your homework. Now it's more going to be your notes to find one that has the rational exponent in it. So heads up, like make sure you do go back and study that. But if you can do the skill that we skipped over, that we'll go back to, promise we'll go back to it, and you know how to solve the radical equation, it shouldn't be a problem. It's just using both skills in the same problem. So, all right. So last bullet point is be able to sketch the graphs of radical functions and state their domain and range. So for this, we need to go over transformations. So for this first one, we have y equals, and you need to know the parent function, okay? So you need to know what the parent function, which is just y equals the square root of x, like what that looks like, because that's the shape that you're going to be transforming. So we know that a negative out front flips it. Now we need to be specific. That flips it over the x-axis, because unlike our other families that we've studied, this actually has 2 flips. You can flip it over the x-axis and you can flip it over the y. So if you just say flip, I have to take off something because you need to be specific. The -1 means it's going to shift right 1, and the +3 means it's going to go up 3. You will be, let me just make sure, you will be provided on your test with a nice little coordinate plane. I'm going to go right 1, up 3. Make sure you get that point clearly marked. I should probably do that with my mouse. I think I can do it. My touch screen is very sensitive there. And then it's flipped over the x-axis. So where the parent function, I'll come back over here to the right, the parent function looks like that. It's the top half of a sideways parabola. If you flip it over the x-axis, it's going to end up down here. So it's going to look like this. You cannot make it look like a straight line. So if you make it look like that, okay, I can't give you full credit. It does have a curve to it, like a parabola has a curve, right? Now for the domain and the range, and you will be prompted on your test with a little d and a little r. Okay, remember that domain is your x's and range is your y's. If I look at this, where's my highlighter? Okay, and I don't want that color highlighter. Let's go back to the yellow. If I look at the x-axis, my graph starts at 1 and it points that way, which means x is greater than or equal to 1. If I look at my y-axis, it starts at 3 and points down. And so since it's pointing down, we'd say y is less than or equal to 3. Sorry, I didn't change out of the highlighter there. You will get partial credit. You get partial credit for just saying, hey, the domain is x and the range is y. You get partial credit for getting the 1 and the 3, and then the rest of the credit comes from getting the greater than or less than. Okay, so that's where the points would be coming from there. Let's take a look at the second one and go back over to my pen so that I'm not making a mess of this. So second one is f of x is equal to the square root of negative x minus 1. In this case, the negative is a flip over the y-axis. Okay, so that's the placement of the negative makes a difference. And then minus 1 on the outside means where you're going down 1. All right. So we're going to go down 1. And remember, the parent graph looks like this. I'm up in the upper left, right corner again. So if I flip it over the y, it looks like that. So it's going to go something like that. And then to do my domain and my range, my domain is your x's, and that is starting at 0. We have the domain, And we remember that that's x's, and it's starting at 0 and it's pointing to the left. Left is less than, so domain is less than or equal to 0. And then remember that your range is your y values. And your y values are starting at -1 and going upward, which means that y is greater than or equal to -1. Sorry, I meant to change the color there. I thought I clicked on it, but here we go. There we go. All right. You do get partial credit for that. Okay, so you do get some partial credit on that domain and that range. There are 2 problems, and they're very similar to these ones. They're actually a little bit easier than these ones. So you're going to have 2 on your test that you need to graph. Now, because I kind of screwed up this PowerPoint and I left out a chunk of things, the next slide is going to show us your assignment. Okay, and then there's a slide after that that just says like questions and stuff, and I'm going to use that slide to go over it. So bear with me as we go through the assignment part of this. And then and then I will I promise I'll review the rest. So your assignment, this is what you're going to need to submit. You're going to choose 3 problems from this study guide that you are the least confident you will be able to do. Now, if you're looking at these and you're like, I feel really confident in all of this, that's awesome. Then choose the 3 problems that are the most complicated. Okay, regardless of whether or not you feel like you'll be able to do them. If you've got more than 3, you can indicate that to me, but I want you to narrow it down to 3 problems from this study guide that you're like, that's the problem that's going to give me a hard time. That's the one that's going to make me panic. Then cover your notes, cover everything you've written down while going through this video, and hopefully you have written some stuff down. And I want you to try to work those problems again on your notebook paper from scratch, from memory. So if you pick like the square root of 45 minus square root of 80, I want you to cover up everything that you wrote down about doing that problem, and I want you to try to do that problem from memory on your notebook paper as best you can. You're not going to be graded on whether you get it right, okay? I just want you to show me what you got from memory on that problem. Circle or write down the part or parts of the problems where you begin to not understand them. So if you're able to start, like you pick one of the exponential, like the simplifying the exponents problems, and you like you're okay for part of it, but then some of it you're like, that part of it I'm not quite following how you got that. Circle it. You can write me a note, say, okay, I don't remember, I need you to explain again how you got whatever, like x to the 5th in this problem. Okay, and then I want you to upload a photo of that to Focus under the assignment study guide assignment. Okay, I haven't put that in Focus at the time I'm recording it, but I'll try to do that as soon as I'm done recording this video. So, or you can submit it at the beginning of class on the review day. Okay, so it has to be in the turn-in bin before we start the in-class review. After we do the review day, I'm not going to accept this assignment, because then you can just do whatever we did in class, and you're not actually doing this assignment. Okay, so this is an assignment that has to be submitted before the review day. Okay, so that's what you need to do. So as soon as I'm done going over the last few problems, then choose the 3, cover your notes, work them again, indicate to me where you're having the issues, where you're having those questions. And if you've got way more than 3, you can give me more feedback on 3. Just, I really want you to try to narrow it down to the most critical, okay? And then upload that to Focus. So if you need to pause the video here and make sure you write down the directions on that. Okay, and then the last slide is post or email me any additional questions. Well, thank you for asking about the chunk of the study guide that I skipped. So this was switching between radical and exponential notation. Okay, this is the chunk that I skipped. So there were 3 problems. How many problems on your test are like this? Let's see. There are 4 problems on your study guide and 4 problems on your test that are of this type. They are like what I consider the freebie questions if you study. If you study, you get this. This is the low-level thinking skill. You just need to move the numbers around. So the first one was the cube root of x to the 4th. all you need to write for full credit on that is x to the 4/3. So you just have to remember that where the numbers go. It's just straight memorization. Now, here's a couple of things I want you to be careful of. You cannot write x to the 4/3 like that. That is a different notation. The 4/3 is the exponent. It has to be in an exponent. That looks like a mixed number, okay? That is something different. I cannot and will not give you credit if you write it like that. So please, 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 please be careful about that. The next one is the square root of x. Now, to answer this one, you need to remember that the index on a square root is a 2 and the exponent is a 1, which means this is written x to the 1/2. That's what I would call like mission critical, because square roots are the most common root, and so exponents of 1/2 are the most common thing. It would be weird if you don't see a square root problem on here, okay? Next one is y to the 3/5. So this is just going in the other direction. So we're going to put the radical, the 5 is the index, the y goes underneath, and the exponent on the y is a 3. Okay. And then the last one on your study guide is y to the 7/4. So this would be the 4th root of y to the 7th, which can be simplified because you'd be looking for groups of 4. Don't simplify it unless the directions ask you to simplify it, because doing extra stuff means that you're opening up the possibility of making mistakes, okay? So you really want to keep it as simple as possible. Do remember, if you have things like parentheses, so if you have like 2x to the 2/3, okay, that when you switch that over, you need to retain the grouping on it, okay? And that goes the other way as well. If you have the square root of xy, when you pull that out, you need to retain the grouping. And we did cover that pretty extensively in class. So that covers everything on your test. I apologize for having that out of order. So what you need to do next is, when the video ends, decide which 3 problems you're going to do, cover them up, give them your best shot, indicate on your best shot where you're having some issues, and basically I'm going to use that information to plan our review day. So you really want to give me as much feedback as possible. I really hope that this video helps and that we get some good questions and that you guys see the payoff of doing the review on your next test. Good luck, everybody.